So hi guys, welcome to the recap or the beta release for p2prc version 1.0.0.0. Um, the updates so far. Okay, so before I start with that, actually, a bit of recap. P2prc is just a peer-to-peer network designed for computation. You can think of a peer-to-peer network to spin up some Docker containers on the server side to execute your tasks. So anyway, so let's get on with it. So to install the project, you can load it from our Git repository, which will be on the description below, and ensure you are inside the project directory. The next thing you want to do is to install or build the binaries and get the paths you need to add to bash rc. For that, we can just do make install. So for now, I'm going to just print them out or create the variables in this current session, but you want to actually no, forgot to copy the second path. But when you're using it, probably you also want to add it to the bash rc. In my case, I have already added it to my bash rc, as I can show you right here. So if you've done this successfully, if you do p2prc-h, you would see that you have all your commands, CLI commands over here. So the next thing is we need a config file, which is very important for the project. And so how do I get this config file? Like, how do I set it up? So it's pretty simple, actually. You just want to make config file. This will run this flag here. So if it's successfully done, you should get something like this. A simple configuration file like this. But as you can see, the IPv6 address part is blank. It's always recommended that we use an IPv6 on the network so that anybody outside the NAT or anybody can access our machine to spin up servers if we want to act as a server. So anyway, so to check our IPv6 address, we can use the flag --ni, which stands for network interface. And as you can see, we have one address over here. So what we can do is just go to the config file and let's add it here. That's it. Once we've done adding our IPv6 address, we can list it. We can see that if it's added by default in our IP tables by doing the flag --ls. So what are IP tables? IP tables are just storing information about servers we know in the network. This one is the default one, which comes with the repository. This is a public server I pay for. This helps keep the network up, so you can download anyone's IP tables, or you can know about anyone's server information who are part of the network because all of them pull each other's IP tables from this IP address for now. But you can obviously set up your own little private network or set up your own you can set up your own server to pull IP tables from. Or actually, if you are running using the flag -s, it does the same thing as what we do. Anyway, so let's talk about how to access a server. So obviously you want to open a new session, and I do p2prc-s. I am a server, and that's it. Nothing more, nothing less. So now we know how to access a server. How do we access a client? So the first question is, how do we get these latencies? To do that, we can just use the flag --us. We're not going to run it now because it takes a while to run, but if you run this eventually, you'll get the latency metrics over here in milliseconds, or mostly in milliseconds. What's important, something else which is important for us would be, how do we create a server? So to do that, we can do p2prc-touch. Before that, let's prove that we can access a server. To do that, we can use a command called specs. If I do this command right here, as we know our current machine is a server, we can view our information about a server. Same thing I can do to the previous IP address, which I found over here. If you wait a second, you can see we have, we can also view the other server itself. So great, we can view our server. How do we create a container? Or how do we create a container in our server? So for that, you have to obviously ensure that you have Docker installed and ensure that Docker is not running as sudo, which is very important because we do not want to execute our binary, or we don't want to execute our CLI commands with sudo. The next thing we want to do would be to create a server. That will be p2prc touch. And probably let's try with this with our local machine itself, because we are acting as a server itself. Let's give it well 4 ports, or let's just give it 3 ports. So as you can see, we could use the flag dash GPU if our machine had a GPU, actually an NVIDIA GPU. So this would mean if you do the command NVIDIA SMI, you can access that interface or access your NVIDIA GPU directly inside a Docker container. But because our machine does not have that in the spec, as we listed over here, so due to that, we can't use the GPU flag. Oops, put the wrong number. As you can see, when we run the command, we have our Docker container, which is created instantly. So to access the container, I'll put SSH master at the IP address, which is this address right here. And I'll give the port, which is up here, 403. When did I paste it correctly? Let's copy this again. Yes, and the password will be, the password is password as specified over here, and we are inside a machine, and we can execute anything we want inside this container. So that's great. Something else I forgot to mention about is the flag called vi, which is viewing images inside the container. This one shows the images we have inside our Docker, the Docker images we can execute. To execute a specific image, you can just put the flag. That would be, I forgot what the flag is. Of course, dash help to the rescue, and that would be view images. Okay, dash cn. And actually, let's actually just run this image for now. Okay, so here would change that to touch, and this time I am going to use the default, we'll use 0 ports and only. As you can see that we've already spinned up we've spinned up successfully and it worked. So these are other images I have set up on my machine, which you can run. Horboard is something very useful if you want to run TensorFlow distributed. So you can have different Horboard images set up in like 70 different computers, which are acting as servers, and you can run a TensorFlow Python script, and then it will execute across all those machines distributed, saving you a lot of time when running trained models. So anyway, apart from that, how do we remove a container? So we've created one. It's important to learn how we remove one. So it's just easy as p2prc --rm, and we can just use the IPv6 address over here, and we can, of course, we want to specify an ID, so of which Docker container we're removing, and that would be, for now, we'll remove this container right here, and we've done it. This means, have we removed it successfully though? p2prc --rm should actually, I think so. Okay. Actually, we don't remove it. What did I do wrong here? p2prc remove vm rm. value dash dash ID. Am I missing anything? Did I specify the IP address correctly? Okay. Maybe my ID was... Oh! I know why. That's why, no wonder. Okay, I put the IPv6 address instead of the ID itself. That's why it was not working. And it should... Well... Anytime soon, it should... Okay, so it removed. If you get this message called success, you have removed the container successfully. So if I do docker ps, we've removed that one container we had. Oops, my phone. So anyway, so we know to create remove containers. What else do we have missing? We'll talk about this in another video. It's still building this. I don't see anything else. I think we are done. So anyway, guys, thank you for watching. I hope do try out the project and join. If you're interested, you can join a Discord channel if you have any questions, and if you have some ideas you think you do for the project to go on further. Thank you.